All right. We have people joining the line. Thanks everybody for attending today's Getting Started with Kubernetes and Rancher 2.0 training. We're gonna have a really good session for you all planned. Just waiting for more people to join the line. Just give it a few more seconds. All right, I think that's good. So we'll start by going over today's objectives, kind of what we want to show you all today, we hope you get out of it today. Essentially, this is a technical introduction to Kubernetes using Rancher 2.0. So we'll go over fundamental Kubernetes concepts, help clarify things that might be confusing, and show you how you can you know take full advantage of everything Kubernetes clusters have to offer using Rancher 2.0 as the management platform. We do have slides, but we're going to keep them to a minimum. This is mainly going to be a demoing and more demoing. Please ask your questions. It's meant to be interactive and hands-on, so you can just put questions into the chat right now, and myself and Kyle will get to them all. We try to get to them all in the 90 minutes that we have. But a little bit of an introduction of myself and my colleague. My name is Matthew Shear. I'm the community advocate here at Rancher. And Kyle Rome is our field engineer on the line, who will be doing a demo and really be the technical backbone for the training. Really good to have you, Kyle. Thanks so much for doing this.
Good to be here.
Yeah. So just a little bit more context before we really get diving into this training. Hope that you have some basic Docker concepts under your belt, what containers are. And if you don't, I think you will still get a lot out of the training. It's meant to be an introduction. And again, if you ask questions that maybe are beyond the scope of the training, we might point you to some other resources like our forums or Slacks or blog articles and things like that. We'll really try to help everybody leave here with a lot more than they began. So if you want to follow along with the installing Rancher and sort of seeing how you can deploy clusters and manage workloads and stuff, as Kyle is going through his demo, then you can install Rancher through this quick start guide. Should get you up and running in just a few minutes. Here is the URL. If you also go to rancher.com and click on the deploy button in the top right, it'll take you to this quick start guide. And again, this session will be recorded, is being recorded, and the slides and the recording and hopefully the Q&A themselves as well will be sent out within 24 hours after the session. Finally, some further resources, our forums.rancher.com and our Slack channel, which is rancher.slack.io, are a great place to plug in. Everything that we're going to be showing you guys today is open source. There's a huge community around it. Really encourage contributions and questions on GitHub and on Slack and the forums. So with that, we're going to start getting into the meat of the material. I'm going to pass this over to you, Kyle. Are you ready to take the reins as the presenter?
Yeah, should be all squared away.
Awesome. Okay, I'm switching it over to you, sir. And I can see your screen, so you're good to go.
Okay. 1 second. Let me just. Okay. So everyone see this quick start guide?
Yep, I can see it.
Okay. So I'm just going to jump over here in Chrome. I already have it up. So there's a few different ways to get started with installing Rancher. This is by far the quickest and easiest. All you're really going to need is a Linux host provisioned in the infrastructure provider of your choice or locally with Docker running on it. So I have a DigitalOcean machine just because it's quick and easy that I stood up. for this webinar is just a single node. This quick start guide, we've kind of packaged everything for Rancher server into one Docker container. If you were to run Rancher server in production, we'd want to set up more of an HA cluster by installing a Kubernetes cluster first and then running Rancher server as an HA workload on that cluster. But for this demo, we're just using this quick and easy guide. So I already have this Linux node that I provisioned. I installed Docker on it in DigitalOcean. Installing Rancher is really as easy as just running this command. So I've already run that command, and you can see I have this Docker container running here. It's exposed a couple ports for 80 and 443. And so by getting my IP address for my DigitalOcean machine, just put this in here. And I'm already signed in, so I land at this cluster page. Other than that, there's some other options you can do for mounting volumes, but you don't need to do that. And then the login page will just ask you for a new admin password for the default admin account. So then we're going to, now that we have our Rancher server stood up, so far all we've done is provision a Linux node, install Docker, and run that one Docker command, and we already are up and running. So now we're going to look at adding Kubernetes clusters into Rancher. Before I do that, any kind of questions about this?
No questions yet, Kyle. So yeah, keep on going.
Okay. So again, I'm just going to use DigitalOcean since it's just quick and easy, and I already have my API key set up. So we'll just call this cluster DigitalOcean, if we can spell. And here I can set up different roles for members and cluster options, but we're not going to look over those right now too much. So we let you pick your CNI, your Kubernetes version. So I'm just going to go with the defaults that we have set up, which is Canal, which if you're not familiar with Canal, is just the flannel CNI with Calico security policies layered on top of it, and version 110 of Kubernetes, which is latest. And then we're going to specify which nodes we want to set up. So there's a few different ways of installing clusters in Rancher. We have these nodes from infrastructure providers where we'll let you set up, we'll provision the nodes for you. Managed Kubernetes providers, where you would just give provide your keys for that specific infrastructure provider, and then we will hook into whether it's Amazon or Google or Azure and spin up one of those clusters based on your configuration options. And then custom and import. So if you have an existing cluster that's already running, but you now want to manage it through Rancher, we can certainly import that in. And then a custom one is you provision the Linux nodes wherever they are. And then we provide you with a Docker command that will use our installation tool, which is called RKE, and I'll touch more on that in a bit. And it just spins up Kubernetes on those Linux machines and reports back into the Rancher server cluster. So, but for right now, the easiest way is just to do from infrastructure provider, so DigitalOcean. I have this template already set up that I will show you guys what that looks like. So it's asking me for my API key. DigitalOcean, you just need one. Amazon, you have your token and secret. Azure, you need to specify your tenant and other things like that. So just based on the infrastructure provider. And so here I can specify my regions, my droplet size, which is just the machine size for DigitalOcean if you're not familiar with that, the user, and then I'm just naming the template, and I can add labels to it if I need to as well. So I can use this now to say I want 3 machines that are defined by this DigitalOcean template. And I want all 3 of these machines, just for the sake, to be etcd, control, and worker nodes. So I could set up different templates if I wanted, for example, my etcd machines to have more disk space and more CPU. And then I could set up multiple different templates for different workers if I wanted some smaller workers for lighter workloads. And then maybe I had a few larger containers that I wanted to run on a little more powerful machines. But for this demo, I'm just going to put everything on one. Make sure to name your clusters. And now we'll see that my cluster is installing. So while this is getting set up, let's kind of go over some Kubernetes basics. So Kubernetes momentum. So Rancher started out as with our 1.0. I think we have a slide about that. One second. I just want to get myself organized. Okay, so interest in Kubernetes has been growing substantially, not just from customers who are using it in production as they start on their container journeys or are switching over from just using Docker to needing some sort of orchestration layer, but also in community engagement. We're seeing a lot more community engagement in Kubernetes than any other container management solution. The Kubernetes scalability and robust design have made it platform choice for the industry. Have a lot of large companies backing it. Obviously, it's a Google product from the beginning, and then many major IT vendors have recently added Kate's offerings. So the managed Kubernetes offerings that I mentioned, whether it's Azure or Google, which has had its for a while, and Amazon, all have their managed Kubernetes offerings that you can leverage through Rancher or outside of Rancher. And here's just kind of that talk of the backing or the breakdown of the backing of different companies that are contributing back into Kubernetes. So the things that we're trying to solve with Rancher, with so many ways to deploy, how do I deploy consistently across different infrastructures? So rarely large companies are going to have infrastructure in either just in the cloud or just private or even just in one cloud infrastructure provider, and managing all those different clusters from dev test to production is a lot of overhead, especially when you're duplicating that across providers. How do I implement and manage access control across multiple clusters? So you don't want to be recreating users and RBAC systems for each of these different clusters. That becomes an entire department into itself. How do I integrate with a central authentication system? So if you're already using Active Directory, you don't want to duplicate that effort for your users and groups. How do I partition clusters to more efficiently use my resources? How do I manage multi-tenancy, multiple dedicated and shared clusters? So if you are a central IT organization and you're doing something as a cluster as a service and you want to be able to spin up clusters for different dev teams, how do you manage all of those different clusters and accesses? How do I make my clusters highly available? So scaling not just your workloads, but your nodes as well. Ensure that security policies are enforced across clusters and namespaces. And monitoring. Do I have sufficient visibility to detect and troubleshoot issues? And we're going to touch on all of those. Kubernetes development is moving at a very fast pace. So you can see some statistics here that I won't read verbatim to you for recent contributions. And the speed in which Kubernetes is evolving. So you can see from 2015 to now all the different versions, and each of these versions has large functionality changes and new resources and new features. So it's not that in 100 days you're getting, just some minor patching. These are new beta features, new alpha features, for all different sorts of resources within Kubernetes. But Kubernetes has a pretty large skill set that you're going to need up front. The learning curve is pretty steep. So users can't really leverage prior Docker knowledge to write Kubernetes manifests. The container knowledge transfers as far as containerizing your applications, but whereas Docker got really popular due to its very simple, understandable Docker build, Docker run, and packaging containers, Kubernetes doesn't quite have that. It's simple, but it's not easy, is a good way to think about it. So with Rancher 2.0, our goal was to ease some of that learning curve and the overhead management of managing from a central point of view many different clusters. So easy to use interface for Kubernetes configuration and deployment. So you guys saw just briefly the Rancher UI there. Infrastructure management across multiple clusters and clouds. You saw, again, just the different infrastructure providers that we can let you deploy. We're not locking you into anything. We're not being, we're not telling you which infrastructure to use. It's bring your own and we'll make it work. Automated deployment of the latest Kubernetes release. We're usually only a few weeks behind Kubernetes for just testing purposes to make sure everything works with Rancher after a new release. And then simplifying workload, RBAC policy, and project management. And then our enterprise grade support. So if you go and start running Rancher server right after this meeting, you're not getting a different version of Rancher that our enterprise customers are getting. It's all the same version. We're completely open source. So we're pretty much just a services and support company from a contract point of view. So here's kind of a view of our complete container management platform. So the user interface, our app catalog, CI/CD monitoring and logging, these are all things that we can help you get started with Kubernetes. And then this is a lot of the developmental operationalizing issues with Kubernetes, how to not only just get Kubernetes up and running with workloads, but how to make it useful for an IT organization. So Rancher helps you get to that operationalized production standpoint much quicker. Unified Kubernetes management, we help with provisioning, whether it's with our node drivers through the UI or our RKE tool, which I mentioned before, which is just a command line tool for installing and lifecycle management of Kubernetes clusters. And that's actually what Rancher server uses as well to install the clusters for, but you can use it yourself to spin up Kubernetes clusters. Upgrading, RBAC, policy, security, capacity, cost, all these things Rancher is going to help you manage. And then we kind of touched on this already, but we can use all of these different clusters within a single Rancher server. So if you're leveraging some EKS, but then you are using vSphere in your private server as well, you can run and manage all those clusters from one Rancher server. And here's kind of the communication flow for Rancher 2.0. So we're not doing anything that all the other Rancher controllers and management components are doing within the Kubernetes cluster, where just everything's running through the APIs to talk to the clusters, to check the health, and to execute deployments and things like that. So now we're going to get into a little bit of Kubernetes 101. Before we do that, I just want to talk a little bit about Rancher's history, because 2.0 got GA'd 2.5 months ago. Is that right, Matt? I think, yeah.
I think it
And
was right at the beginning of May. So, what is that? Almost 2 months.
yeah, so prior to 2.0, Rancher 1.6, if some of you might be familiar with that, was a kind of choose your own container orchestration story where you could use Kubernetes or Docker Swarm or Mesosphere, and we would help you manage all of that, essentially much like Rancher 2.0 does for Kubernetes. However, we saw that the market share of Kubernetes and the community embrace of Kubernetes kind of pointed in the direction that that's what was going to kind of win out the container orchestration wars, if you will. And so Rancher 2.0 is a completely new product from the ground up. It's accomplishing a lot of the same stuff that Rancher 1.6 was. A lot of the UIs even very similar, but it's all pure Kubernetes. It's all written in Go. And so we're not doing anything in a kind of non-Kubernetes way. All of your deployments and everything, if you wanted to still attach for some reasons just through kubectl and did deployments and created different resources, that's completely fine. We're not going to get in the way of any of that. So just to rebase different Kubernetes resources, this is probably review for a lot of you, but it's, I'm sure, new for some. And so we'll just kind of go over these different resources and what they look like within Kubernetes. So first off, pods are the smallest unit that can be deployed in Kubernetes. Pod consists of one or more containers, and they're always scheduled together. So you can have multiple replicas of a pod, but each pod, all those containers are going to be scheduled together. So that means that they're going to share a local host, they're going to share file access and namespace, things like that. Each pod is given a unique IP address. That's important because all pods are going to be routable within the cluster. So that's an internal IP address. You can expose them externally, but we'll get to that as well. Containers in a pod can speak to each other via localhost. So the routable network within Kubernetes can be managed a few different ways, but you're definitely going to be using a CNI container network implementation, I believe, which is usually going to be Flannel or Calico or Canal. So if the explanation is confusing, if you're coming from a Docker background, don't worry too much. Pods typically contain only a single container. You would just be adding multiple containers to a pod if they are working together for a single point and you don't need to scale them independently. So you can think of pods as containers for the rest of this training, but just realize that there's more to them that you can leverage if needed. So replication controller and replica set, these are pretty much the same thing, but a replica controller. I always get this confused. The replica set is the newer version of what was the replica controller. Defines the desired scale and state for a group of pods. So I want 3 replicas of my pod running in my cluster. So you'll see 3 different deployments of that pod through somewhere on a worker node within Kubernetes. And then one level up from deployment, from a replica set, is a deployment. And a deployment is creates and updates your replica sets. So if you want to change any of the settings in your replica set, allows you to easily perform rolling upgrades. So you can define all of your pods and what images are in your containers and your replicas all within a single deployment resource file. So next up is services. There's several different kinds of services. Define a DNS entry that can be used to refer to a group of pods. So a service is going to help with the routing of pods. So if I have 3 different pods, I want a single point of access to those pods. I don't want to have to keep track of where my pods are all the time, especially if one goes down and then comes back up and I have another application that's relying on routing to those pods. I can't expect that I will be able to know exactly where those pods are at all times. So that way we just route to a service. A service is going to have a pod selector saying these pods with this label are what I'm managing, and then it'll be able to route internally to there. So this is just providing us with a consistent endpoint for the group of pods. Different types, node port. So node port is allowing Kubernetes to pick a external port in the range of, I forget exactly what it is, but it's like 30,000 to 36, something like that, and expose that port on each node where my pod is running. A cluster IP is going to be an internal service for my pod, so making it routable inside through a service, or leveraging Ingress, which I could point to that cluster IP, which we'll talk about in a second, or a load balancer service. So you can set up your Kubernetes cluster with a cloud provider. So if I'm using, say, Amazon, Kubernetes has a feature called Cloud Provider that you can set up with your infrastructure provider, and so it'll be aware of where it's being hosted, and you can set up a service that, if it was in Amazon, a load balancer service would be set up through your cloud provider and be able to route externally an IP address to your pod. So in that case, it'd be an ELB in AWS or an Azure load balancer, wherever you're hosting it. But if you don't have a cloud provider set up and you're trying to use a load balancer, that's just going to spin and never actually come up. Nope. So next type of resource, and one thing to remember is these are all just resources within Kubernetes. So a resource is just anything that you can define really with a YAML file, and you can do create through kubectl, create or apply. So that's really how Kubernetes works at a base level. Is I can go in, create my config map, create a service, create my deployments, create accounts. The creation workflow for all of these things is exactly the same, obviously with different options and definitions, but these can all work together in the same way. So a config map is just a way to decouple your application's configuration from your deployment. So if I have a different config map that I need in staging than production, I can deploy that config map, modify it in both, and then decouple that from my application logic, and then just tell my deployment to, in my deployment YAML file or for my pod, to use the configuration in this config map. So config map's just going to be key value pairs, pretty much, and exposed in pods as either environment variables, which you can define in the YAML file, or as local storage, so you can mount the config maps as well. So Ingress, which I just touched on briefly, define how traffic outside the cluster is routed to inside the cluster. So the kind of community Kubernetes default is Nginx, but there's other Ingress controllers as well. So you can, they're used to expose Kubernetes services to the world. So if you have a Kubernetes service that routes to all of your pods, but you still want a public IP that is going to point at that service, you can use an Ingress resource with an Ingress controller to route to that service, which will then route to one of the pods that's running. So route traffic to internal services based on factors such as host and path. So with your ingress resource, you would say route, to this container at this path, whether, that's slash foo. Ingress is usually implemented by a load balancer. So I mentioned Nginx, HA proxy, AWS ELB. And then these can also integrate with some other external load balancer that's going to be aware of your ingress controllers. So if your ingress controllers move, you don't have to change the IP addresses that you're routing to. Okay, so now we'll jump back to the cluster. Any questions kind of on those resources? These are the topics through the UI that we're going to try and cover in the next hour or so. Try to be quick, get you guys back to work or watching the World Cup or whatever you're doing.
Cool. There are a couple questions. So you might actually end up answering these as you're going through this Rancher demo or this Rancher explanation. Peter asks, what do you mean by a cluster? Like, what is a cluster? Is it a virtual machine server?
Okay, that's a good question. So a cluster in Kubernetes is a collection of nodes. So whether those are VMs, which is often the case, whether that's in some local host using VMware or something like that, or if they're in the cloud, it's some set of Linux hosts that are going to have a set of roles. So a cluster in Kubernetes, there's really three roles for nodes that you'll hear about. Master nodes, or control nodes as we call them in our Rancher UI, worker nodes, and etcd nodes. So when I installed that cluster before, you saw that set of role options that I was defining. So when I spun up this cluster, I specified three nodes. So these are just three Linux servers that got spun up in DigitalOcean. And then I specified that I wanted them to be control, etcd, and worker. So that means that these three Linux nodes are hosting each of those roles for Kubernetes on each server. So etcd is kind of the brain of Kubernetes, has all the information about the state of the cluster, all of the deployments and services and things like that. The master node is a set of Kubernetes components that from the API server, so the way that you're going to interact with the cluster, and then the Kubernetes controllers, which make sure that the current state of all of your well, the scheduler and then the controllers, and those maintain the state of all of your deployments. So if something goes down, making sure that a new resource gets scheduled somewhere else on the cluster. So oftentimes in production, those roles will be split out on different Linux servers so that your worker nodes where your applications are and your containers are getting deployed to aren't using the same resources as, say, your API server. So they're not competing for resources. And same for etcd, where it's usually bottlenecked by IO for file, but you would still usually want to separate those concerns in production. But in this demo, I have all those roles on each of these three servers. So a cluster can be one node, which obviously wouldn't be highly available, but for a demo purpose, you could certainly do that. It could be 100 nodes. So I could scale this cluster up to another node. I'd get another etcd, another master, and another worker, since I only have that one template. But usually you'll have 3 etcd nodes, at least 2 masters, and then X amount of worker nodes. So I hope that explains kind of what a cluster is.
Okay, great. A couple more questions. Is that all right before you continue? This is a follow-up question. Peter says, I always thought that Kubernetes was just automation to run Docker images in one big cluster and orchestrate it. And Rancher was a GUI for Kubernetes to run Docker images. But from the presentation so far, it seems that Rancher is an alternative to Kubernetes and yet uses it somehow. I do not understand what Rancher's relation to Kubernetes and Docker is. Can you explain that?
Sure. So, yeah, Rancher is certainly not an alternative to Kubernetes. Kubernetes would be more of an alternative to something like Docker Swarm. It's a container orchestration management tool. So it's a way to ensure that your containers that you want to run can be routed to, are highly available, can interact with other containers and services, and the orchestration layer can manage the state of all of those resources and route to all of them and expose the proper ports and apply security policies around them, things like that. So Rancher is using Kubernetes as its container orchestration layer. It's not competing with that. It's giving you a different way to manage your Kubernetes uh, clusters, and it's giving you centralized management for things like RBAC for applying, authorization and authentication to all of your clusters, which without something like Rancher, you'd have to do individually with all of your different clusters. And it's making the learning curve for developers deploying into Kubernetes a little easier. So those are kind of a couple things, and I'll through this UI show you the different advantages of Kubernetes. You can certainly run Kubernetes without Rancher and interact with it through kubectl, which is fine if you're just have one cluster that you're playing around with. But once you get into an IT organization where you're deploying multiple clusters, and maybe you have clusters in the cloud and you have some private ones, managing all those clusters becomes a lot of overhead, and that's really where Rancher comes in.
Hmm. That's great. There's other questions, but many of them I think you'll cover when you get to the add clusters part of the Rancher demo. Um,
Okay.
and so maybe at that point you could take another pause.
Okay, so we already talked about setting up Rancher. I just went through and showed the kind of quick start where we're deploying that one Docker container that has all of the Rancher server and Kubernetes stuff all in one simple container. I mentioned that if you're running it outside of like a demo or a testing environment, you probably want to use RKE. So I'll just touch on that briefly. So RKE is our Kubernetes CLI installation tool. So if anyone's ever installed Kubernetes the hard way, which is getting all the components and just manually installing them on a bunch of servers by yourself, it's real frustrating. So RKE is just a command line tool to set up a simple, well, it doesn't have to be simple, Kubernetes cluster with all of the different command line parameters. And so you would, in a YAML file, define what your cluster looks like. So give it the IP addresses of your master or control nodes, your worker nodes, your etcd nodes, and specify different parameters for setting that up. And then RKE up will create a cluster out of those nodes that you've provisioned previously. RKE is not a provisioning tool. And then you can then deploy Rancher server just onto Kubernetes itself and run it so it's highly available and resilient. So that's how you would usually set up Rancher server in a production environment. You wouldn't just use this one Docker container. So clusters. So if I go, so now that we kind of talked about all of those different Kubernetes resources, we're shifting back context to Rancher. So Rancher, this is the Rancher UI, and you can manage all of those different resources through this UI. The first one being clusters, which I was standing up before we started talking about Kubernetes resources and did that whole 101 thing. So now I have this cluster that stood up in DigitalOcean. So it's 3 DigitalOcean machines that all have the same specs. So 2 cores, 4 gigs with some attached storage. And I can just see some health checks and the resources that are being used, as well as some other information for each of these nodes. And right now I haven't really deployed any workloads onto this cluster, so only the things that Rancher installs by default will be here. So when I mentioned this before, but Rancher is not going to get in the way of you doing anything native to Kubernetes. So we even give you the ability to launch kubectl into this cluster right from the UI. And then I can check, what pods are running on this cluster. And you can see we have a few different things running. So Canal is running because that was the CNI that I chose when I was setting up this cluster. kubedns is running, and Nginx, which we deploy as just a daemon set, which is a type of Kubernetes deployment where it specifies that one instance should be running on every single node. The default HTTP backend, so this is what you fall through to for Nginx when routing, and cattle nodes, which are our agents reporting back into the Rancher server. But I don't have any other workloads. And then these are the namespaces so kubesystem's a default Kubernetes namespace that you're always going to have. And then we set up cattle system in Ingress Nginx. So the only difference right now with this cluster from if I was just setting up a bare Kubernetes cluster and this one is our agents that are talking to the Rancher server that we're looking at. And we've already deployed some Ingress for you. Matthew, were there other cluster questions that I should take now?
Yeah, let's see. Alfredo asks, is it better to use 3 etcd and 3 masters? And maybe, yeah. So is it better to use 3 etcd and 3 masters and then the worker nodes? I don't know. You might need
Yeah.
more.
So if you're trying to set up a highly available like production cluster where you don't want all the roles to be on the same nodes, usually you want at 3 or 5 etcd nodes, depending on kind of the scale of your cluster. etcd works on a quorum base. So to be highly available, you need half plus 1 is the general rule for maintaining your cluster being up. So with 3 nodes, that means 1 can go down as long as you still have 2. And if you had 5, that meant 2 could go down and you would still be running with 3. The reason for that is to avoid split brain issues. So if I had, say, 2 etcd nodes, and maybe they didn't go down, maybe they just stopped communicating with each other, I would then have 2 different sources of truth for maintaining the state of my cluster. And then obviously that's going to screw up things real quick. So if one node can't communicate with the other 2 when you have 3, then it's considered offline, and the other 2 can see that, okay, I can still communicate with the other one, so we're still in quorum and we can still function. Master nodes, you really just want to maintain your HA capabilities for those master components I mentioned, your schedulers, controllers, and your API server, things like that. So when you're starting out, 2 is good, but you can also run your masters and etcd on 3 nodes. You just want to make sure that you watch the resources for them. etcd is usually IO, whereas your master components is usually going to be memory and CPU constrained, but oftentimes those are also split out. So that's usually more on a case-by-case basis. And then your worker nodes can be whatever sizes you need based on the size of the containers you're deploying to them, the amount of replicas you need running, and the amount of room you might need for growth. Say you have a container that Friday at 5 o'clock, it's some time tracking thing, and that's when all of the resources get hit for it. You want to be able to scale that deployment to manage the most demand for that application. And then you might have some containers that are much larger in size. So you might want to scale up rather than out on a few worker nodes so that they have more resources. And you can also apply resource limits for applications and namespaces. So you can say, I don't want this application running out of control and taking up all the resources on this node, so I'm going to limit it to this much CPU and this much RAM.
Excellent. So, and on that note, Justin has asked, so you're talking about this 1, 3, or 5 for etcd. Is there a reason the number of nodes are limited to 1, 3, or 5 rather than just odd numbers?
After 5, you start to see some performance issues with the communication between etcd nodes. If you're scaling above 5, there's probably a reason you're trying to scale up, and there's probably a different answer to fixing that issue. So if it's an I/O issue, adding more nodes isn't necessarily going to help that. And it might be you have to look at the storage you're using for your nodes, or maybe your cluster has gotten too big and you need to split that cluster into different purposes. There are I forget the exact amount of nodes that you can have on a cluster. There's a default limit for pods on a node and nodes in a cluster. You're usually not going to hit those unless you're a huge organization that's spinning up containers constantly and spinning up nodes and bringing them back down. But yeah, 3 or 5. 3 gives you HA, obviously, for etcd. 5 gives you 2 points of HA. So you could have a node down in maintenance and still maintain high availability, but that's also just kind of default Kubernetes recommendation that we also suggest. We're not changing anything about that.
Cool. Yeah, there's more questions on other topics, so you feel free to keep going.
Okay. So with this cluster, if I look at this, I'll go back up to global first. I just want to, okay. So at this global level, think of yourself as kind of the Kubernetes central IT administrator, right? I might have a bunch of different clusters here, and then these are the options that will apply to all these clusters. So the node drivers this is when I click add cluster, which of these options are enabled. You can create your own node drivers, but more than likely in a production scenario, you're going to be creating a lot of custom clusters. So the reason for that is a lot of organizations already have some provisioning automation for their nodes, whether that's through something like Ansible or Chef or Puppet, and they don't want Rancher managing the provisioning of those nodes. A lot of times they'll have specific libraries or things that need to get installed, so that gets managed externally. So then with custom, I'll just show you quickly what this workflow looks like. We give you this Docker command, so you would already have your nodes provisioned at this point. Whatever those Linux servers are, as long as they are some version of an OS that Kubernetes supports. We're not changing anything about the versions of Docker or the OSs that are supported. So we're just taking those straight from Kubernetes support. So Rancher isn't changing anything about those versions that get supported. And then you would say, okay, I'm going to run this Docker node, Docker command on a node that's going to be etcd and control. You can see it's just adding these flags here. Maybe I want to add some labels here. And again, it's just adding a few command line parameters along with the node address. And then I would just run this Docker command on that node. And once I run this command on all of those different Linux servers, it's going to stand up a Kubernetes cluster and report back into the Rancher server. And then I would be able to interact with it there. It says it's provisioning. Obviously, that's not going to work, so I'm going to delete it. So that's node drivers. Catalogs, I'm going to kind of do this out of order. I'm going to do it more in the UI order. Catalogs, if you're familiar with Helm, this is really a UI that we just put on top of Helm. So Helm, you can kind of think as the Kubernetes package manager. So in Helm, you can define a chart, and that chart is a way for your application to get deployed in a standardized way. So by default, we have a kind of library of curated charts that are a little more Rancher aware. So they might use our um, ingress or have changes to storage requirements rather than in Helm stable. Oftentimes they're standing up their own Nginx ingress controllers and services on top of what we already have deployed. So you would just might have to modify those a little bit if you're using our ingress definition. But I can certainly enable that here, or you can add your own catalog. So if you're using Helm to deploy your applications in Kubernetes, this is just going to ask for a catalog URL. So if I have a GitHub repo with a charts folder in it, I can just specify that here, name it, and then users will be able to deploy those charts within a cluster that they have access to. So you can manage access to these charts as well through roles. And I'll get to that in a minute as well. And I'll just show you what that looks like for deploying catalog apps. So you can see I only have the library chosen because in the global settings, that's all that was checked. And then I'll look at Prometheus, which is a monitoring tool and a pretty standard way for doing monitoring in Kubernetes. And this will give me the README for this Prometheus chart. I can see all these configuration options and all of these options for this Helm chart. So if I say false, I'll get a bunch of other questions about, okay, what image do I want to use? All these questions down here, all this UI, if you wanted to create something like this for your own Helm chart, we just created, we're just consuming a, there we go, a questions.yaml file. And so this is just another YAML file that you can package with your chart that we will consume and create this UI based on these variables and definitions. So I know I kind of jumped ahead there with catalogs, but we'll get to deploying applications in a second. And then obviously, since I just stood up this Rancher server, I'm not authenticated through any other access control. But here, if I wanted to set up Active Directory, I could give it all my Active Directory settings here, and then rather than having to create users for Rancher through the UI, I could just leverage the users and groups that already exist within Active Directory. We also have Azure AD, GitHub, and we will soon be adding Open LDAP and SAML support as well. That's coming within the next few weeks, I believe. So before I go, okay. So before I go any further, are there any other questions? We're going to go through deploying workloads. We're going to talk about Ingress. We're going to look at services. We're going to deploy a catalog app. And I'm going to talk through how you use Rancher to apply role-based authentication or authorization through for multiple clusters and what that looks like. So if you have any questions around those things, I am getting to them. But anything else?
There's one quick question from Justin. He asks to confirm that Rancher 2.0 is fully written in Go. Is that right?
Yep.
Okay, cool. That was it. You keep going.
Yeah, and so you can look at our GitHub, and if you're really want to get involved, you can submit PRs or things like that. It's fully open source, as well as our other projects like RKE, which I mentioned. So you can see the repositories for those as well. So let's look at roles. So authentication, you can set up your users and groups through some external auth. And roles, these are just the default set of roles. So all of these are going to be doing. It's probably easier if I lister. So this is probably not a real role that you would need, but say I wanted to create a role that I just wanted people to be able to list pods. So add a resource, it's going to give me this list of verbs. So these are your kubectl verbs, where it's not as fine grained as kubectl. Obviously, there's other things you can do with kubectl, but these are the roles that manage those functions. And they're also going to manage the functions through the user, through the Rancher UI, as well as the Rancher API. And so I can just I can create this role. And that's now active. And I can, if I had another user, I could grant these specific roles to that user, either at the global level or at a cluster or project level, which I'll get to in a second. So let's now go into so now we're in there's 3 different contexts that you're going to be in the Rancher UI. There's the global level, the cluster level, and then the project level. So a project is a Kubernetes custom resource that we've created that's just a logical grouping of namespaces. So to back up, I know that was a lot in one sentence, but so everything from like your deployments, your services, your pods, your replica sets, your ingress, these are all resources that are by default defined by Kubernetes. But Kubernetes also lets you create your own custom resources if you want. So we have a few different ones, but projects for this demo sake, really the only one that you're going to need to know. And so namespaces in Kubernetes are just logical grouping of names, and you can set RBAC around them so that people can only access certain namespaces, things like that. But so we've just created projects which sits a level logically above namespaces, and then we apply RBAC at that level. So your projects might look like Dev Team 1, Dev Team 2, and then within Dev Team 1, maybe your namespaces are your applications or different services within an application, things like that. So here I can see I just have my default project right now, and within this project I only have my default namespace. Now I have a second namespace, and these are your namespaces that are not in a project. So these are the Rancher server created ones that we saw before when we were looking in kubectl, and then kubepublic and kubesystem are your default Kubernetes namespaces that have some different Kubernetes components within them. So I could also add a project. I can apply a pod security policy if I wanted, but we're not going to go over that right now. And then I can also add different members. I don't have any other members or users or groups in this installation right now since I just spun it up. But you can see I have these different roles and this pod lister one, which I just created, and I could give them those roles for this new project as well. And that's really how we're managing RBAC for Kubernetes through Rancher. So now I have a second project. I have a namespace for app A, or APA as it now looks. That was a foolish name. And I also have my default project. So I can give different people different access with different roles. So maybe someone is an owner in my default project, but in Dev Team 2, maybe they can just look at resources. They can't deploy or delete. So let's now go down to at project level. And this is where you're going to deploy your applications, set up Ingress, set up your deploy your catalog apps. And I can also see the members for this project. So if I had added other projects in when I was just creating that project, they'd show up here and I can see what roles everyone has. Again, now that we're down a level, I don't see the project level, I just see the namespaces, and then I see the ones that aren't in a project. So now let's move on to workloads. So deploying an application in Kubernetes, you have a few different options. So a deployment, which we talked about, is going to be your default workload type and the one that you are going to be using most often, most likely. And I can specify how many replicas of this pod that I'm going to be deploying within this deployment I want. So let's say I wanted 2, run 1 pod on each node. That's the daemon set that I mentioned earlier, and that's how we're running the Nginx ingress controller, so that each node is currently also an ingress node. So if I had some other external load balancer, I'd want to point it to all those different nodes. Stateful set, cron jobs, and regular jobs are other type of deployments. We're not going to go into those too much right now because I'm quickly running out of time. And then I can just specify a Docker image. So this is just going to pull from Docker Hub repo. I can add, or registry. I can add other registries that I might want to pull from. So if you're using ECR or GCR or Quay or something like that, you can add URLs and credentials within Rancher, and then when you're deploying the workload, it will be able to know which registry I should be pulling this from. So for right now, I'm just going to, I have a sample app that I want to deploy. I'm just going to leave it in the default namespace. I created that other namespace before. I could add it there. And then I'm going to create a node port, which was that service type that we mentioned before, or I could give it a specific port. I'm not going to do that. I'll let it pick. And I'm just going to expose the container port 80 for this image. If I have other environment variables that I want to set, so if I was using a config map and I wanted to set them through environment variables, I could do that here. If I have storage that I need to attach, if I want to change how this application scales, all these things you can do through Kubernetes, but we've just given you the option to set all these things right through the UI. So I'm not going to change any of those. I'm just going to expose the port, specify my image and my namespace, and remember that I put 2 for the deployment, and we are going to watch this hopefully spin up. While we're doing that, any questions?
Yeah, there are several. So let's see. Let's start with Jay asks, are projects and namespaces Rancher concepts or Kubernetes constructs?
Namespaces is a Kubernetes construct, and a project is a custom resource that Rancher has created to help manage role-based authorization. So hopefully this works. I don't know why it's taking so long, probably because I'm presenting. So namespaces is always going to be in Kubernetes, but a project is really just something we created to help you manage roles and role-based access a little easier, because if you've ever tried to do RBAC in Kubernetes with just namespaces at a large scale, it gets pretty unwieldy managing all that. This is You can keep going with other
Okay,
questions.
great. So Damien asks, and thanks for your patience on this question, Damien. He asked it a while ago. He says, is Rancher replacing the standard Kubernetes pods in the kube system namespace? And is it possible to continue to operate a Kubernetes cluster when Rancher is not running?
Yes. So if Rancher server goes down, your cluster is still going to be up. We're not doing anything. You can create whatever namespaces you want. Obviously, the kube system still exists there. Um, the one thing I will say, if Rancher goes down and you are using, say, Active Directory to manage all of your users and groups for authentication purposes, if your Rancher server goes down, that authentication is going to break, and then your users won't be able to access the clusters using those accounts. So since the authentication is coming through the front door on the Rancher server, if it can't get through there, you're not going to authenticate properly. So that being said, obviously your applications would still be running, everything in Kubernetes would still be running. And if you had a Kubernetes like administration account or something, you could still go in and use kubectl and manage things that way. You just wouldn't be able to use that authentication hook, since that is through the Rancher server and is not something that is that you can do just through a Kubernetes cluster.
Okay,
So
cool.
I wrote this Docker image incorrectly, which some of you probably saw and were laughing at. And that is going to be an issue. So now that I can type, this application has come up quite quickly. And you can see I have these two pods. I can exec into these pods, which you can do with just like kubectl exec, but often that's kind of annoying because you have to list your pods, you have to find the pod name and then exec into it. So we're giving you that just through the UI. I can also view the logs for this pod. And then every resource in the Rancher UI, I'm going to be able to view the YAML if there is a YAML file to view for that resource, and then view an API. And I'll get to that in a second. But the YAML file, so if you've deployed anything in Kubernetes before, this is how resources are defined through a YAML file. So there's a bunch of kind of stuff that we've added in here. So usually they're not going to be this long for an application so simple. But you can see my namespace is in here. This is for this specific pod. So I am looking at the YAML file for this pod, not for the not at the deployment. You can see that it's owned by a replica set for this, which is the one that we created through this deployment. So when you're deploying a workload through the Rancher UI, a lot is happening in the background. We're creating a deployment which has a replica set, which is controlling those pods. So if I look at the YAML file here, you can see this is the deployment. So before I was looking at the pod, which is part of this deployment, and now I'm looking at the higher level deployment YAML. And you can see replicas is 2, which I specified in that UI. And here's the image that I wanted to pull. And here's the port that I exposed. And we can go look at this as well and how that's getting exposed. And there's a little other information in there that you usually won't have to look at. You can see the full status of the deployment here as well. So now I have this node port endpoint that if I click will bring up this application. So this is just running on one of those nodes. It's being exposed by that node port on this randomly chosen port in that node port range that we were talking about before. And so now there's two sets of this application running, and they're running on the same port. I'm not sure which, and I can go see which node they're running on as well if I wanted to. Also, when you might have saw when I was editing the image name that it actually didn't update. So if I got the image name wrong again and say I realized that it was right the first time or I needed to roll back for some other reason, I can choose that earlier replica set because every time you edit a workload through the Rancher UI, we're creating a new deployment with a new replica set. And so I could choose this one and it'll show me the difference here. So this is the change that I made. Um, and I could roll back to that previous one. So, or say I wanted to edit this and say I was wrong and really the container was port 8080, which it's not, so that node port's going to go nowhere. But just to show you the upgrade, you can see the status of those pods as it's removing and spinning up new ones. And now those two pods are up and running again, and I could then roll back to, so you can see it chose a different port here because I'm just randomly assigning it. And I could roll back to that previous version as well. So in the service discovery, I have just this simple service, which gets created with my workload. All this is doing is that it's just a service named game as well. And then this value is the workload that it's pointing out. So it's a little confusing. Services and deployments and things like that, they don't have to, their names won't interfere with each other. So I just have a service called name that's pointing at my workload's name and is keeping track of where all my pods are routable to. I can set up those other services that we talked about before. This is just pointing at workloads. You can set up an external service. So this would be a service running on Kubernetes, but would be pointing elsewhere. So if you needed to route externally for some reason, you can do that. I can also route internally to a different IP address. Usually the one you're going to be using the most often is one or more workloads, or the set of pods which match a selector. So with resources can have any resource within Kubernetes you can set labels on. And then if I wanted to route to, say I had multiple versions of this game application running, and I wanted to set up a router that routed to the older version, I could set a label on that for the version, and then I could just point to those labels rather than the deployment, and then the service would only route to that older version. And you can use that for a few different things as well. So that's the service that got created when I created that workload. So this workload is creating my deployment, the pods within the deployment, and the service for it. So say I didn't want to expose a node port and I wanted to use ingress instead, using the Nginx ingress controller that's on, that we've deployed as a default. I can specify my namespace again. So we have this integration with XIPIO. All this is giving me is a publicly addressable name. XIPIO is really just going to take the IP address of wherever this is running and append XIPIO to it, and kind of just is a quick way to do DNS without me having to actually set up DNS for this application. So I'll show you what that works like. Obviously, if you're running in production, you will probably have a host name with the proper certs already set up. So you'll probably be specifying that for your ingress definitions. And then I just want to go to my default path for my game application on port 80. If I have other certs that I want to set up for this, I would specify them here. And this is going to register in a second. You can see now I have two node ports here, and that's because I have two pods. I don't know why it wasn't showing before. They might have just both been on the same. Ba, ba, ba. So this hasn't registered yet, so this is just explaining what XIPIO does. So I'll get an IP address appended with this, and it's just a quick way to do wildcard DNS. So now it's um, created, and we can see that name I specified, game site dot default, which is the namespace that it's in, dot this IP address dot XIPIO. And so now I'm just hitting it through a wildcard DNS entry that's kind of cheating through XIPIO rather than using the IP address with a randomly assigned node port entry. So in production, obviously, if you had like company.application.com or something, you could set that up here with your proper certs, and then you could use Ingress to access it that way. So we kind of jumped around a little bit. So we talked about setting up Rancher, cluster, went over some authentication and security, talked about projects and namespaces. So I'll touch on storage and then, I'll deploy a catalog application since we already talked a little bit about that. And I'll touch on storage as well as the CLI, API, and kubectl. I have 13 minutes. Are there other questions that I should answer before getting into that?
Let's see. There are definitely other questions, but I think finishing your presentation takes priority,
Okay,
and we'll try to
so
get.
I'll go quickly so I can try and leave a few questions. Storage, so I'm at the cluster level right now. Yeah. So storage in Kubernetes is, you could go to a week-long class on this by itself, but if you're familiar with storage classes, we're not doing anything fancy. You can select a provisioner. So if you're using just say Azure Disk, if this was in Azure, which it isn't, so that doesn't make any sense. Or if I have a custom provisioner that I wanted to use, or if I was using Gluster, I could create a storage class. I'm going to have get all of my parameters that I need to set up for whatever that provisioner is, and then that will be able to create persistent volumes. I'll go over just kind of the high level details. For in Kubernetes, if you need persistent volume that's going to live outside the scope of your work, outside of your pod, or even outside of your deployment, you would use a persistent volume. And so here I would be able to create a persistent volume on whatever storage solution. So if you have an NFF server, or if you're using iSCSI or whatever, you would set up a persistent volume here with the proper sizing and wherever it lives, and Kubernetes would have a link to a section of storage for that storage provider. And then within my workload, I would add a persistent volume claim. And in the persistent volume claim, the workload is saying, I need a persistent volume that meets this criteria. You can say it needs to be this type of storage. You can say it needs to be this much storage. And then Kubernetes will say, okay, these are the persistent volumes I have available. If the claim matches one, your cluster will get assigned that, and that persistent volume claim will bind to that persistent volume. And then your application will be able to leverage the storage for that persistent volume. And then if your deployment goes away, the persistent volume lifecycle exists outside of that. So then you're not going to lose your data. If you just have temporary data, you can obviously just use like an empty folder or something, or volume. It doesn't need to be a persistent volume. So I don't have a provisioner set up that I could create storage, but that's kind of the long and mostly short of it for storage. If you just need to mount an endpoint for your application, you can do that. You don't have to do all this persistent volume, but obviously just be aware if that pod dies, then that mount point is going to go with it. So that's more for your temporary data if you need scratch space or something like that. And then the catalog. we already talked about the catalog. I'll just show you what deploying one looks like. So we already looked at Prometheus, so I'll just use that again. And I'm just going to use all these defaults. Yep. Okay. And so I'm going to launch this application, and it's going to work a lot like the workload, but the chart defines all of the services and ingress definitions and all the different pods that are getting deployed for this application. So you can see that if I click on this, there's a whole lot of different endpoints and workloads and ingress rules, and there'll be some services and a secret getting set up as well. Secret is just, we're not doing anything unlike just standard Kubernetes. So a secret is just a key value pair that you might use for different endpoints or passwords or users within Kubernetes. You can also use things like HashiCorp Vault. We're not integrating with Vault on our own, but you can certainly do that just like you would any other Kubernetes cluster. So this is just other key value pairs similar to a config map, but obviously for secrets. So if I go back to the catalog app, this is now up and running. And I have Grafana set up in front of Prometheus, which is just kind of a dashboard for monitoring and there's a few different charts set up by default. So I could use this to monitor my pods, or I can look at my nodes usage, and you can see the graph is just starting. And you can create your own charts if you know Grafana and Prometheus, and do all sorts of fun stuff and set up alerts. You can also set up alerts within Rancher, and you can set up notifiers for those alerts. So we have hooks, if like anything that takes a webhook or Slack or email, you would be able to set up alerts for and send notifications to those different things by default. And we also have some other tools that I haven't had time to get to that are a little more advanced. And you guys can certainly reach out to us after this if you want more information. And we also have some deeper dives on individual topics. I know we just had one on networking that was very good. So if you have a lot of questions around Flannel and CNIs in general, or just Docker networking, which I think everyone in the world does who uses this, I would highly suggest watching that if you have the time. I think that's just on our YouTube channel. So Matthew, you might want to mention that at the end of this.
Yes.
Other than that, the API, just quickly, so I showed you how you can use kubectl. You can download this kubeconfig. Kubeconfig is just a way to tell your local kubectl what cluster to point to. So if you're running kubectl on your local machine, you could download this file. We tell you put this into kube./config, and your kubectl would be able to communicate with your cluster that you spun up on Rancher. In the API, so if I go here, every resource other than being able to look at the YAML, I can view an API. So this is the deployment, and so say I wanted to roll back, this is going to give me the curl command or HTTP request to interact with this through the Rancher API. So our whole user interface is just backed by our API, and so anything you're doing in the UI, you can automate through API calls as well. So if I went up, now I'm looking at workloads, and if I wanted to create a workload, it's going to give me all those same fields that I was just doing through the UI, and then show request, and again I get that curl command, HTTP command. So this is one of my favorite things about Rancher, is that we just show you all of this API interactions by default. If you want to manage or create an API key, that's going to be under your user here. So we have a few things that are using individual API keys by default. So this is my UI session that's going on right now. These are the kubectl shell user. So when I was using kubectl from the cluster, that's what I was using. Or if, say, my CI/CD pipeline need an API key to interact with Rancher, I could create one, set expirations for it, and then leverage that API key. It's going to show me my secrets or my bearer token right here, and then I can just use that to execute any of these commands that we're using within the Rancher UI. So I know that was especially quick there at the end, but any questions about that?
Yeah, so let's just go down the list. Alex asks, and we just have a few minutes here, but Alex asks, so kubectl works directly with Kubernetes or just via Rancher?
kubectl is your command line tool to interact with Kubernetes. So when I'm at the cluster level and I'm launching kubectl, I'm not doing anything through the Rancher API. This is all just hitting the Kubernetes master API endpoint, which is exactly how Rancher is interacting with Kubernetes. We just have our API that's aware of all of these, kind of a layer on top of kubectl that lets you manage things a little more fine-grained and lets you do Rancher-specific things like manage projects and RBAC and things like that through the API. So whichever way you're doing, you're going to be hitting the same points. We're not doing anything weird with etcd or anything. But kubectl is going directly to your clusters. The Rancher API is going through the Rancher API server and then hitting the Kubernetes API.
Cool. Okay, next one. Alfredo asks, for multi-tenancy, is it best practice to assign one project per tenant or multiple projects per tenant?
That's really going to be case by case. So if you have a tenant, it's really going to be defined by when do I need to give users different access. So if there's a single dev team, but maybe a user is an owner for a specific application, and then maybe he's just a contributor, or he just needs access to view settings or something in another one, you can set it up that way. So it's really going to be up to you on just what's the easiest way for you to manage the different access controls that your developers and administrators need.
Okay. Next one, thanks, Kyle. Next one is from Edon. I hope I didn't butcher your name, and thank you so much for your patience with this question. This is a bit of a troubleshooting question, Kyle. He says, I keep getting stuck at waiting for etcd and control plane nodes to be registered when deploying the Rancher agent on an existing server. What am I doing wrong?
That very well could be a port issue. So in our documentation, we have the ports that you need open. So you need ports open not only from the Rancher server to your cluster, but you're going to need ports open from your cluster to be able to talk back to your Rancher server. So I would first check that communication is open. Make sure you don't have any weird corporate proxy things getting in the way from between where your Rancher server and your cluster is trying to provision. Outside of that, if you're on the Rancher user Slack channel, my username is at krome, Krome, and I would be happy to help you out there as well. Or you can just ask in general, and there's a good amount of interaction there. And then the forums, as Matthew mentioned, as well, as an option.
Awesome. So I think actually, we will end it there because we are at time. There's a few more questions from Alex and Hunter and Sangeeta and Peter, but please put your questions on Slack and on the forum, and we will try to get to them. Also, you'll get an email with the recording and the slides afterwards. I'll try to make a note that you guys didn't get your questions answered, and we'll try to follow up from there too via email. Was there anything else you wanted to show, Kyle, before we close out?
No, I kind of rushed there at the end. Sorry for if the pacing was a little off, but it's certainly a lot to get through. And like I said, if you guys need more information, we have deeper dives on specific topics that are recorded that you can see on YouTube. And then we also have our forums and Slack channel where you can reach out to us.
Right. I'm gonna take the presentation back here just to show them the URL of the Slack channel. So slack.rancher.io. And again, we have these intro trainings every week. So the next one will be next Thursday, also free to join. So if you still have questions, you need to see it again live. Um, and each presenter does it a little bit different, so you can definitely join that too. And Kyle, you did an awesome job. Thanks so much for taking the time and going through all this different information with us. And
Yeah, hopefully it was somewhat helpful.
yeah, I learned a lot. And thanks everybody for your questions. And yeah, you'll be hearing from us in your email with the recording and the slides soon. So have a good day, everybody. Talk to y'all soon.